Hello. What I want to do today is give a quick start guide to Visit on how to get started using Visit. The first thing is, what is Visit? Visit is a data visualization program. It's used to look at data that's in a finite element mesh. So if you have a mesh consisting of nodes and elements, generalized geometry, you can look at it in Visit. Visit is an open source visualization tool. It's developed by Lawrence Livermore National Laboratory. There's another tool called ParaView that's also a very good tool. It's also open source, but I tend to use Visit just because I'm more familiar with it. So the first thing is, how do you download Visit? So I've given the website on the page here. It's Lawrence Livermore National Gov and Visit. So if you just do a Google search on Visit and Lawrence Livermore, you should be able to get to it. But here's the website if you get it. I've pulled up the web page. If you open up the Visit site, you can see the web page, and then there's some download links. You can download it for all the different computer configurations. You can get source code, you can get Linux executables, Windows executables, Mac executables, etc. It's open source, so go ahead and download Visit. Okay. All right, once you have Visit installed on your computer, the next thing to do is generate some data files. All right, so we have a little utility. I don't want to spend too much time on this, but we have a little utility to generate VTK files from diff3d files. And so if you run diff3d, here's an example on this screen in the black. So the input file, the diff3d, is this .input file. If you run diff3d, you'll get many different data files. They all have capital letters and 6 letters. So you can see compxs, geodist, isotox, labels, rtflux, etc. Most of these you'll never use. There's a few of them. They're all binary files. Geodist, that's your geometry file. Isotox, that's your cross sections. You may use that in other codes. And rtflux is the flux file, so your flux output file. So diff3d is a fairly old code. It creates all these 6-letter data files that tend to be small, all the data in. It doesn't really help you for visualization. If you run a little utility code we have called hex core, it'll actually read the diff3d.input file and the rtflux file, and it'll create these VTK files and SVG files. And so I'll tell you what these are. So the VTK files, these are your mesh files. These are actually just data ASCII files, so you can open up with the data with any sort of editor. Let's look at one. You can see it's just a list of numbers. So the first point is the points. These are all your nodes, so your X, Y, Z of your nodes. Then if you scroll down this file, it's a big file. You'll see all your nodes. You'll see how the elements map to the nodes. And then if you keep going, there'll be data. For example, the group 1 flux, the group 2 flux, etc. And they can either be defined on a node or an element. You won't need to know exactly what's in the VTK file, but if you're curious, it's there. So we have the .vtk files. Real quickly, it also creates these SVG files. An SVG file is actually a format that's used to create graphics for HTML files. So if you open this up, this SNR3D has 4 different unique levels in it, and so it creates these 4 different SVG files that you can open up in a web browser. I've already opened these up. So you can see the first level. Here's the first level. You can see there's no control rods in it. There's another file for the next level where it starts to have, or the bottom level is a reflector. Then you start to have control rods in it, more control rods, and then the top reflector. So these pictures are nice. If you want to, you can take them to a web page. You can create other formats, PNG files, JPEGs, etc., and stick them in reports if you want to see a core loading. It's not really related to Visit. It's just one of the data files that's produced by this core. What we want to focus on is these VTK files. All right. So now going back to the agenda. So if we're on step number 2 is generate the data files, VTK files and SVG files. SVG files can be opened in your web browser. VTK files are a lot more data. You can open that in Visit. All right, going on to item 3. Now we want to load this data into Visit. Okay, so if we open up Visit, you'll get 2 windows like I've shown here. Your controls are on the left, and on the right-hand side is the actual data visualization. One thing to notice is this window on the left is usually a little too small, so we just want to drag it and make it a little bigger, and we'll see this variables thing pop up. It's sort of a pet peeve of mine, but it doesn't quite show up, so you have to make this window a little bigger. Then go to the top, File, open a file, all right, and this path is where you put your path, and you'll have to type in your path to see the files. And VTK is, Visit is very powerful. It can open up all different file extensions. It tries to be smart. Unfortunately, it's usually wrong. So the first thing I want to do is this file grouping, turn it to off. All right, now you have a list of your files. We go down. 6.VTK is the 6th core. The straight VTK is the full core. So we open up the SNR3D FD VTK file and just hit OK. All right. You open the file. It's going to take a while to read it. It's a fairly large ASCII file, so we'll let it read it. OK. And you'll see that nothing happens. All right. So the next thing we have to do is tell it what we want to visualize. All right. So there's many things on the file. So if we go over to the controls, this add button, which just popped up in green, we go down, we have a lot of different selections. But the first thing we want to do is look at the mesh. So we select mesh and then the mesh again, click on that. Again, nothing happens. And then we have to hit this draw button. So you select what you want to do. We want to look at this mesh quantity, which is the mesh, and hit draw. Wait a few seconds and the mesh comes up. It's a 3D mesh. So if you go over to the visualization window and you just select your mouse, you can select it and move it around. You want to kind of look at your mesh first to make sure it looks reasonable. So this is exactly the mesh we want. There's nothing strange sticking up or nothing out of order. So it looks like a reasonable mesh. This is what we want. It's not very pretty though. It's just a picture of the mesh. So the next thing we want to do is actually look at some of the distributions on the file. Okay, so this is the mesh. Go over to add, select add, go down to pseudo color, and then you'll see a list of distributions that are on the file. First is the BC is the boundary conditions, flux 1, 2, 3, and 4. These are the flux in different groups. Hex number, this is just a geometry edit that tells the number of the hexes. Materials, you can look at the different material numbers on the things. And then there's some edits at the bottom, which are mainly debug edits, the ring numbers, the ring positions, the X position, Y position, Z position. This is just sort of make sure that our files are working correctly. For this example, let's look at the material number. So we hit material, nothing happens, and then we hit draw. Okay, now we have a picture of the mesh and a picture of the distribution, right? We can move this around and look at it. Unfortunately, what we're seeing the colors is just the outside of the core, which tends to be fairly uniform. At the top of the core, you can see where the control rods are. Okay, all right, that's step 3. So let's go back to the agenda here. So we've generated the data files, we've loaded them into Visit, start Visit, open the data files, we can view the mesh, and we can view distributions. Okay, real quickly, let's go to change colors. So sometimes our color distribution, if you're looking at a continuous distribution, for example, flux or power, you want your colors to be nice and smooth. However, if you're looking at something like material numbers, we're looking at integer numbers between 1 to 6. We don't necessarily want a smooth range of colors. We'd actually like discrete colors to make them look out. So the first thing we want to do is we want to look at some of the plot attributes. All right, so we want to look at the plot. So we're going to go up to plot at the very top of the controls, the header files. If we go down, bear with me. Okay, it's in the controls. The controls menu, go down to color table. All right, so go to the control window, the controls menu, color table, a window will pop up. And in this window, there's at the top, you can see continuous variables is this hot. For materials, if you select that, you can see all the different colors. There's many different colors. The hot is the default, which looks fairly nice. Sometimes if you have a lot of things, there's something called the hot desaturated, which is a nice thing to look at, makes nice colors. You see that in the castle pictures. They use this hot desaturated a lot. We're going to go ahead and select this amino shapely or amino rasmal. All right. And what this is sort of a discontinuous colors, and hit apply. Okay, if we hit that, now you can actually see that at the top, there's 3 different colors at the top. I'm not sure which one this corresponds to, usually 2 or 3, but now you can see 3 different colors. But this is just one option if you want to change your colors. Let's go ahead and change this back to the default hot scheme. Okay, and hit, again, you have to hit apply each time, right? Not as pretty. So if you want to look at the material numbers, maybe go to the amino thing. All right, back to the agenda. The next thing we want to do is create 2D slices. Okay, so we have a picture of our core. We can see the outside, but we can't see what's inside it, so it's not very interesting. So what we want to do is take a slice. So the first thing we want to do is go back to op attributes. This is we're going to put in an operation on the plot. All right, so op attributes, and what we're going to do is we're going to take a slice. So go up to op ats, and then the slicing, and then select the slice. Okay, a window's going to come up. All right, slice attribute. So what kind of slice do we want? The first thing we're going to do is make a slice in the radial direction. So the radial direction is going to be perpendicular to the z-axis. So we've picked the normal is going to be orthogonal to the z-axis. And then we want to know where is this slice going to occur. We can pick the axial level. So if you look at your plot, we'll scroll it up a little bit. You can see that the z-axis goes from 180 to about, or from 0 to about 180. So we can pick our z-axis intercept. We'll pick it at 90, right in the middle. You can also, sometimes you can hit the percent and click 50%, 20%, but the intercept, if you know where that's at. So we have, it's orthogonal to the z-axis, intercepts at 90, and we want to project this to 2D, and we hit apply. It asks you if you want to apply it. Yes, we do. All right, and nothing shows up. So if you look over on your left control, you see that everything's kind of fuzzy. So we've applied, we still have the mesh, and a slice has been applied to it. The pseudo color, a slice has been attributed to it. And now we need to hit the draw button again. Okay, and now you can see, now we have a 2D picture. All right, we've taken a slice, the radial slice. This looks very similar to those SVG files. So another way to get a radial slice that's doing this. Now take right now, remember we're looking at the materials. We can change the distributions that we're looking at by going over, first we can hit add, we can add another distribution, but there's a quicker way to doing it is this variables plot. If you pull down the variables plot, you can see all the different options on here. Right now we're looking at the material numbers 1 through 6, but we can look at flux 1. You can see it's very quickly. We can go through, here's flux 1, now pick flux 2, flux 3. You can start to see the control rods. So flux 1 and flux 2 are very high energies. They look kind of a sine wave, and now you can start to see the control rods with the mean free paths are smaller. In flux 4, you can really start to see some of these things, the mean free paths in the flux 4. The other things to look at is the hex number, right? It's not very interesting, but you can see these are numbers 1 to 328, and the numbers are very close together. So if you wanted to look at this, it might be better to change the color scheme to the amino color scheme. Another one is the materials. We look at the materials, and before, when we were looking at the 3D core, we only saw the outside material. Now you can see 1, 2, 3, 4, 5 different materials on here. Okay, corresponding to the material numbers 1, 2, 3, 4, 5, and 6. All right, so that's a good way to select the variables. Okay, let's go back and make a different slice. So let's go ahead and we'll go to the slice window on the far right, and we'll dismiss this. Okay, and we can go to the left, and we can go to our operators, and we want to remove all the so we did a slice operation. We want to remove all the operations, and then we go back to our 3D picture. So now we're back to our 3D picture. Okay, again, go up to operation attributes, slicing, do a slice, but let's do a slice on the y-axis. So instead of taking a radial slice, we're going to look at a slice that's orthogonal to the y-axis. Again, if we scroll around, you can see that the y-axis goes from -100 to 100 approximately. And so we want to take our intercept right at 0. So go to our slice, it's going to be orthogonal to y, and our intercept is going to be at 0 this time, and we apply. Again, nothing happens. Go over to the draw, hit draw, and we get our slice. That's not very interesting. It's not very interesting because it doesn't go through a control rod. So let's go back over and let's change our intercept a little bit. Let's say to 10, apply. Okay, now you can see we've moved that the intercept, and now we're going through a control rod. We can change it again. Let's try 30. I'm not sure if this will work. Okay, now we get 1 control rod. So where you change that intercept is going to apply it. Let's go back real quickly to a Z plot. Intercept is 70. Apply that. Okay, now if we look at here, you can see where those control rods were. So if you look at the across the Y, you can see it didn't intercept any control rods. We moved it up to 10. We got 2 control rods. If we moved it up to a little higher, so this is 10, maybe 15. So let's do Y-axis, intercept at 15. We should be able to get 4 control rods. And we do, we get 4 control rods. 4 control rods, and they're at different levels. So if you want to look at slices, you can play around with where your intercepts are, either a Z-axis or a Y-axis. Again, we can go over to variables now, and we can select our different variables. This is the materials. We can look at flux 1, flux 2, flux 3, flux 4. Flux 4, you can start to see the things. And we looked at materials and ring numbers. One thing I'll point is boundary conditions. If you see the boundary conditions are this the type. So most of the problem has 0, and then on the outside is a 3 boundary condition. Now it looks a little strange because they have gradients going from 3 to 0, but if you actually looked at the files, it'd be very discrete, a 0 and a 3. Okay. All right, so now we know how to do slices. Slices are nice. You can do a slice, you can make a picture, you can put it in a presentation, you can look at different things. All right, so let's go back to our agenda. All right, we've created 2D slices. The next thing we want to do is look at 3D cuts. A cut's a little different. It's a little nicer picture. Put this in the background. Okay, so first thing we want to do is let's get rid of the slice attribute. So we're going to go over to operators, remove all. So we're going to remove our operator that we applied, and we are back to our picture. All right, we got back to our 3D picture, and we are looking at flux 3. Again, it's not very interesting because we're just looking at the flux on the outside of the core, which it tends to be very small. So that blue is at 1375, which is almost 0. And you can see at the center of the core, it's 10 to the 6th. So it should be a red color. So we want to see what's in the middle of that core. We could look at a slice, or the other thing we want to look at is actually called a cut. So if we go to op attributes, and we're going to pick a selection and a clip. We're going to clip it. All right, we get a clip window that comes up, and this tells us how we're going to clip this volume and just look at a portion of it. And so there's 3 different planes. We'll go through this, but the first plane, you have to, again, pick the origin that you're normal to, and then where you're at, the normal vector. So the first thing we want to do is we want to make it orthogonal to the y-axis. So the normal will be 0, 1, 0. Okay. And then, because that's the y, the normal is coming out of the y plane. And then our origin, we'll leave it 0, 0, 0. We hit apply. Nothing happens. We go over and we hit draw, and we get half of the thing. We've cut the problem in half at 0. So if we scroll it around, we can see what happens. So it's a little fancy. It looks kind of like a slice, but we get the full 3D effects. That's kind of nice. We can do even better. So we can add another plane in here. So let's add a second plane. It's going to be orthogonal to the z-axis. So we want to make our normal 0, 0, 1. At the origin, we want this, remember the z-axis goes from 0 to 180. So let's pick, we don't want in the center, let's pick somewhere around 40. So we have 2 slices, and we hit apply and draw again. All right, that didn't work. Okay, the reason is the origin was 40, 0, 0, and we want it to be 0, 0, 40. So it was at the very bottom of the problem is our Z was at the very bottom of the core, so it didn't work. All right, so now we have our origin at 0, 0, 40, which should be a radial plane. We hit apply and you can see, okay. Now we can look at it too. So we've cut out a section of the volume. We can increase the 40, we can increase it up to maybe 60, hit apply, and you can see. So you can see how you can select, you can cut out different regions of the plane. This is nice. Now we can actually add a third plane on this. And the third plane, let's start off with let's make it a 45-degree line. And so our normal, we're gonna make it X and Y be 1, 1, 0. Keep the origin at 0, hit apply, and we should get 3 planes here. And we got 3 planes. Okay. So we can kind of make some nice pictures here. Okay, we can, instead of a 45-degree angle, we're cutting a lot. See, we have if you look at the top of it, you can see we're cutting a lot of these triangles. We can try to make it, instead of a 45-degree angle, we can make it try to make it more of a 30 or 60-degree angle. Went the wrong way, we'll go 2, 2, 1. So you can kind of play around with your normal, try to put in the square root of 3. Oops, I hit the post button by accident. The post button is actually just gonna move that window over to your control window. We're gonna unpost it. Okay, so we have our 3 planes, 2, 1, 0, apply. Okay, so you can play around with that a little bit. Maybe we're gonna move our Z down a little bit, back down to 40. Okay, but that's basically how you can make cuts of your geometry, and this makes nice figures that you can put in presentations. So, and we can scroll it around, look at the different angles, et cetera, et cetera. All right, that's all I have for the cuts. Okay, we're gonna dismiss this window. We're gonna keep the cut there. We're gonna dismiss this window. All right, going back to our agenda, we have the 2D slices, we have 3D cuts. Now let's look at some things we can do to save our pictures and make them a little prettier. The first thing you'll notice is we can save a snapshot of this window. It's pretty easy, but there's a lot of extra information on here. For example, there's this text at the top, there's my name on the bottom right, we have this bounding box. So we want to remove some of these things. And the way that we do this is we go up to File, Controls, and then it's the annotation control. So if you hit annotation, this is sort of a busy window, but this has all these annotations are in this menu. The first thing as you can see is the legend. We can turn off the legend. We hit the button, apply, the legend goes away. I kind of like the legend on there, so we'll go ahead and keep the legend. I'll click the button and hit apply. So we want to keep the legend. What we want to do though is take off, it's called a database with the file name. We don't want that file name at the top. And we also want to take away that user information on the bottom right-hand corner. So I unclick the database and user information, hit apply. You can see those go away. In the lower left-hand corner, you can see that they call it a triad. We can take that away too, and then these bounding boxes. Before we do that, let's go up to the general. We have to go from general to the 3D. If you have if we have a 2D plot, use the 2D tab, and you can take away the axis. But we have a 3D plot, so go to the 3D plot where it says show axis. We want to take that away. We want to take away the show the triad, and we want to take away the bounding boxes. Apply that. All right, that looks like a much better picture. All right, that's a nicer picture that we can put in a presentation. All right, now we want to save this. One thing to say is we are plotting the grid lines on here. You may want to keep the grid lines on there. You may want to take them away. If you have a lot of if you have sort of a coarse resolution, I kind of like keeping the grid lines on there. If it's a really fine resolution, we can take the grid lines off. And the way we do that is go to the control panel, hit the mesh. We can either delete this or just hide it. So I'm gonna hide it at this point and then draw again. And you can see now we have our same picture with no mesh lines on it. Okay. I don't like that so much, so I'm gonna go ahead and put the mesh back on there. So I'm gonna show the mesh, keep it like this. But if you want to take away your mesh lines, you can do that. All right, so we have the 3D picture, we've had our slice, we're gonna keep our meshes on there. Now we actually want to save our picture. The way we do that is go up to File, Save the Window. Okay, it comes up there. This one doesn't give you much controls. It's going to save that window as a PNG file, and then you'll be able to put that into your presentation. So it saves it to a PNG file. I don't know why, but it doesn't ask you for any information. It just makes a file. It puts it in your visit directory. So if you look in your main document visit, and it calls it visit 00000001, etc. It just keeps incrementing it. So I already have 11 pictures in my directory, so we made it 12 here. We dismissed that. Let's say I want to move this around, come up with a couple of options, maybe look at it from the top view. I can go up to File, save the window again, and you can see now, if you look at the bottom of the control panel, it saves it as file 13. Okay, so every time you save something, it just increments it. Okay, I think that's everything I wanted to cover on this. So let's just kind of recap it. So we can download Visit, generate the data files, load the data files in a Visit. We can view mesh and distributions using the control panel on the left. We can then change the color palette to different color palettes. We can take our 3D distribution, make 2D slices out of it, create 3D slices, and then finally we can save our picture. If we want to save pictures, we can remove extra information, and then we can save it as PNG files. I'll show you the PNG files in a second. I just wanted to point out there's a lot more options we can do here. It's a very powerful tool. One thing is if we can make movies out of this. For example, if you have a dozen different or a dozen or 100 or something simulations, you can actually make a movie out of them. And the way you do that is you just number your VTK files with the 0.1, 0.2, 0.3, 0.4, and the code's actually smart enough where it can pick those up, and then you can create movies with that. So that's a more complicated option, but it's available for you. There's a few more operator attributes. You can go up to the operator attributes. You can just try different things out. You can do smoothing and sampling. One thing I do once in a while is the selection. You can actually do a threshold. So if you go to selection, threshold, and this is kind of nice. For example, you can see our flux goes, several different orders of magnitude. Well, what if I don't want to see? I want to get rid of sort of these zero flux values. I can set a lower bound. So maybe in this plot, I can set a lower bound 10 to the minus 5. So just I went up, I had an operator attribute 1E5, apply that, and then again draw. Oh, we got an error on here. All right, so we did a scalar operator on a non-scalar. I'm not sure why that happened. I'll dismiss that. But you can see the edges here are sort of jagged, right? I don't know if this is very useful, but sometimes you just want to look at the high power densities. Maybe let's raise that. Let's raise the attribute up 10 to the minus 6. Apply that. Okay. I get kind of a funky picture, maybe not very useful, but it is kind of, sometimes you want to look at threshold plots. So that's available too. Now it's an operator attribute, so we can go up to our operators and we can remove the last operator. That gets rid of the attribute. Okay, now we're back to our picture. We can go back to our mesh, draw the mesh, add the mesh lines. So there's many different things you can do in it. All right, so let's go ahead and close down Visit, and I want to show you where those files were. So if you go to your documents, there's a directory called Visit, and it's called My Images, and you can see all the different images that you've created. Now in this session, we've created Visit 12 and Visit 13. You can see I've done other images in the past. Here's a BWR image. This came from a mesh generated from Impact. William, Don, and I were looking at triangle meshes. So here's a triangle mesh. Here's another triangle mesh. So you can see how it's really powerful, and you can look at different pictures, but it uses the same things. So you pull in a VTK file, you look at meshes, you look at attributes, etc. Okay. All right, that's all I have. And let me know if you have any questions, send me an email, and I'll stop now. Thank you.